5.4 presentation part 2. So I worked some problems in class, and here's some of the ones I did, showing the different ways you might be able to do the integration by parts. First one we're going to do here is the integral of arctangent x dx. Now this book doesn't look like there's two parts here, but there kind of is if you think of this as one separate. Usually there's two different functions and a dx, but there's only one function and a dx. So we'll do the u sub, or the integration by parts, not u sub. So I have the function and their derivatives and their u and v, and I'm going to let u be this part because I don't want to have to take the derivative of dx. That would be the second derivative, and I don't want to go there. So I'm going to put arc tangent here so that when I take its derivative, which I hope you remember is 1 over x squared plus 1 dx, and I'm going to put the dx here, which is like 1 dx, and the antiderivative of 1 is just x. So this becomes u times v, x arc tangent x minus the integral. This came from the problem, so this is the new problem. X over 1 x squared plus 1 dx. Now that doesn't look like a real simple thing to integrate. This we don't have to, but we've got to integrate this. But if you do a u sub, but we have a u over here, so I'm going to call it a w sub. I'm going to let w be x squared plus 1. The derivative would be dw equals 2x dx, and so dx would equal dw over 2x. And so we get x arc tangent x minus, I'm going to leave that x there, and this is going to be w, and dx is dw over 2x, and the x's cancel. The 2 can come out as a half, and so I just got the integral of 1 over w dw, and 1 over w integrates to ln w. So I have x arc tangent x minus 1/2 ln of w, but w was x squared plus 1, and I would normally do absolute value, but since x squared plus 1 is never negative, I can just don't need the absolute value. I get x squared plus 1 and plus c. Now let's check that by taking the derivative and make sure that we get back to arctangent, because I don't want to do something here and mess up and then have to fix it for you. So if I call that a and this b for this product, the derivative of a is 1 times b. So this is a prime b plus b prime a, and the derivative of arctangent is 1 over x squared plus 1 times a, which is x, and then we have minus 1/2. The derivative of ln of something is 1 over the something times the derivative of the inside, which is 2x, plus the derivative of c, which is 0. So this is what I have. And the 2's cancel, and so I've got negative x over x squared plus 1 and plus x over x squared plus 1. Those cancel, and I'm left with just arc tangent x. So The derivative of this is arctangent, so this is the antiderivative of the arctangent. Okay, the next problem I want to do is the integral of x to the third sine of x squared dx. And they tell you to think of x squared in the book as x cubed. Think of it as x squared times x. I'm just going to do the simple u substitution. But since we're doing u's and v's for the integration by parts, I'm going to call it w substitution. I'm going to let w be x squared. dw would equal 2x dx. So dx would equal dw over 2x. So this problem would turn into the integral. We'd have x to the third sine w, and for dx we have dw over 2x. So the 2 can come out and be a half, and this x will cancel one of these x's and make this x squared. Changes from x to the third to x squared. But x squared is w. So we have 1/2 integral of w sine w dw. There's the half. That's x squared is the w, sine of w dw. Now it's all in terms of w, so we can proceed, and now we can do integration by parts. U and v, and I'm going to let w go here so that when I take the derivative I get 1 dw. I'm going to put sine w dw here. The antiderivative of sine is cosine w, although that would make negative sine, so we have to make it negative cosine w. So this would become uv, which is negative w cosine w, minus the antiderivative of not these way, but this way, which is negative cosine w dw, these two. Well, the minus of minus is plus, and I have a half. Forgot to put the half in there. I'm going to make a mistake here yet. This is minus, and so all this is times a half. So I got 1/2 minus w cosine w, and then 1/2 times this, so that's plus 1/2. The antiderivative of cosine is sine w, and then plus c. So now let's take it back to the x's. W was x squared, so we have minus 1/2 x squared cosine x squared plus 1/2 sine of x squared plus c. All right. Now, we could have, when we did this integration, that could have been inside these big brackets at plus c, and so the half would have been times c. And it would be all right to write that, because half of any number, because a constant's any number, could be any other number, and so it really doesn't matter if we keep it a half c or a c. Anyway, take the derivative of this to check. So I'm pulling out the blue pen. We have A, B, this is a product. This is not a product over here. The product and chain rule. So the derivative of A would be 2 times negative half is negative 1, x to the 1, so negative x times b, which is cosine of x squared. And then we have plus b, the derivative of b, the derivative of cosine is negative sine of whatever it is, times the derivative of the inside, which is times 2x. That's the b prime. So this was a prime b plus b prime. And now I got to do a, and a would be minus 1/2 x squared plus 1/2. The derivative of sine is cosine of the x squared times the derivative of the inside, which is 2x. And then the derivative of c is gone. So hopefully this simplifies to be x to the third sine x squared. Let's see. The 2's here cancel. And so I've got cosine of x squared times x. And I have minus cosine x squared times x. So this and this cancel. And hopefully what I have in the middle here is x to the third sine x squared. Well, this 2 would cancel the half. The minus here would cancel the minus there. And so I have sine of x squared times x squared, which is x to the third sine x squared. So that works. There was a lot of cancellation and changing things going on there, so you've got to be real careful when you do these. Okay, now let's do another one. Because I did it in class, I'm trying to go through it in case you were unable to attend or need to review it again. So now I'm going to do the integral of x to the fifth e to the x to the third dx. And they want you to split this up. I'm just going to say, okay, I'm going to let w, since I might have to do some u, I'm going to let w be x to the third. dw would be 3x squared dx. dx would equal dw over 3x squared. So this would become the integral x to the fifth e to the w, and dx is dw over 3x squared. The x squared will cancel 2 of these and leave x to the third. But x to the third was a w, so we get the integral of w e to the w dw over 3, which would be 1/3 on the outside. So now we're going to do it by parts. So f, the derivative of f, u, v. We're going to let u be the w. And so the derivative would be dw. And I'm going to let e to the w dw be v prime. And so v would be e to the w. And so this becomes uv, w e to the w, minus the integral of, I got a third here, got to remember that, 1/3 times all of this. The integral of these two, which is e to the w dw. But that's an easy one to do, so we have 1/3 w e to the w minus 1/3, and the antiderivative of e to the w dw is e to the w plus c. Now going back to my x's, w to the third, w was x to the third, so we got 1/3 x to the third e to the x to the third minus 1/3 e to the x to the third plus c. Checking our work. Call this a, this b. A prime would be x squared. 3 times a third is 1, x to 1 less, x squared, times b, which is e to the x to the third, plus the derivative of b, b prime, that would be e to the x to the third times the derivative of the power, which would be 3x squared. That's the derivative of b times a, which is 1/3 x to the third. So that's b prime a. This was a prime b plus b prime a minus the derivative of this, which is 1/3. Derivative of e to the x to the third is e to the x to the third times the derivative of x to the third, which is 3x squared. And the derivative of c is 0. So we have x squared e to the x to the third, and we have minus x squared e to the x to the third. These two cancel. So if this equals x to the fifth, e to the x to the third, we're in good shape here. We have the 3's canceling, the 1/3 and the 3. We have x to the third times x squared, which is x to the fifth, e to the x to the third. So that matches. So this is a correct antiderivative. All right, let's do another. We having fun yet? Okay, this time we're going to do the antiderivative of e to the 2t cosine e to the t dt. So I'm going to let w be e to the t, dw would be e to the t dt. So dt would equal dw over e to the t. So this problem would become the integral of e to the 2t times cosine of w, and dt becomes dw over e to the t. Now, e to the t is a w, and e to the 2t is e to the t quantity to the t, because when you got to take a power to power, you multiply. And so this is w squared. So this w cancels one of these w's, and I end up with the integral of w cosine w dw. And then doing by parts on this, I'm going to let the u be w. So its derivative is dw, and v to v prime to be cosine w dw. So its antiderivative is sine of w. So this becomes uv minus the integral of these two, which is sine w dw, which is w sine w. The antiderivative of sine is negative cosine w plus c. And w was e to the t, so we have e to the t sine e to the t plus, minus minus is plus, cosine e to the t plus c. If I check my work, if I call that a and b and do the product rule, a prime is e to the t times sine e to the t plus b prime, so the derivative of sine is cosine e to the t times the derivative of the inside, which is e to the t, times a, which is e to the t. So this is the derivative of b prime, and this is a, this was a, and this was a prime, b, plus the derivative of cosine of e to the t. The derivative of cosine is negative sine of e to the t times the derivative of the inside, which is e to the t. And the derivative of c is 0. So now I have e to the t sine e to the t minus e to the t sine of e to the t. These are opposite and equal, so they cancel. And here I have e to the t times e to the t. When you multiply, you add the powers, so you get e to the 2t cosine e to the t. So that shows us that this was the correct antiderivative of that. Continuing on. Now we're going to do one that's the integral of x squared cosine x dx. Okay. It never really does much if you do a u substitution or a w substitution for x. If it's just x, it doesn't help much because it just changes the x's to w's. So we're going to do this by parts. F prime, the function and its derivative, u and v. So I'm going to cosine. If I let it be cosine here, then it keeps kind of cycling. And I don't want to integrate this because that gets it to the cubes, and I want to get less. So I'm going to put the x squared here. So when I take the derivative, it becomes 2x to the 1 dx, and I'm getting this to decrease. It's not gone, but it's decreased this function. And the rest of this, cosine x dx, the antiderivative is sine of x. So this would be x squared sine x for uv minus the integral not of these two, which is what we started with, but these two, which is 2x sine x dx. And we could pull the 2 out, or I could leave it in, doesn't matter. But it looks like I want to get this to disappear, this x, so we don't have a product rule. So I'm going to do the u sub again. And I really don't need to keep the u and the v on here because we don't use it other than to keep things straight. The function and its derivative. So for u, I'm going to put the 2x. Its derivative is 2dx. And I'm going to put sine x for the derivative of v, sine x dx. Antiderivative of this would be negative cosine x. So this becomes x squared sine x and minus all of this. So it's important to put the big bracket here. And now we're going to do uv, which is negative 2x cosine x minus the integral of these two, which is 2 negative 2 cosine x negative 2 cosine x dx. So now it's going to be important to keep things straight. A lot of minuses and pluses and everything, and this is where you can get fouled up. So we've got x squared sine x. And this is a minus, which is plus 2x cosine x. And this is minus, which is plus, but this minus makes it minus the integral of 2, and that 2 can come out, cosine x dx, and that's the integral of cosine is sine. So we got minus 2 sine x plus c. Okay, let's check it. So I got a product here, I've got a product here, and I don't have a product there. So doing this one, I'll call this A and B, and so for the A prime, I get 2x times B plus the derivative of B, which is cosine x times A. Now I do it again, A and B for this product, and derivative of A is 2 times B cosine x plus the derivative of B, which is negative sine x times A. And then we have minus 2 sine x, whose derivative, the derivative of which would be derivative of sine is cosine, so minus 2 cosine x, and the derivative of c is 0. All right, let's see what we got here. 2 cosine x minus 2 cosine x. Good. 2x sine x minus 2x sine x plus, they cancel. Good. So it looks like I have x squared cosine x, which is what I wanted to find the antiderivative of. So this must be the antiderivative of x squared cosine x, because when I take the derivative, I get it. All right. Now we're going to go to this one. Again, this one doesn't look like it should be integration by parts, but it is. One of them is going to be dx, and the other is going to be ln x. And I don't want to take the derivative of dx, so I'm going to put the 1 dx down here and ln x here. And I don't mind taking derivative of ln. I don't want to have to do the antiderivative of ln, because that's what we're trying to do, the antiderivative of ln. So I wouldn't want to put it in this table here. So f and f prime, this is u. The derivative is 1 over x dx. The antiderivative of 1 is x. So this becomes x ln x minus the integral of not these two, but those two. X times 1 over x is 1 dx. And the integral of 1, the antiderivative of 1, is just x. So we get x ln x minus x plus c. So let's see if this actually is the antiderivative of ln x. We have a product, a, b. So we take the derivative of the first, which is 1, times b, plus the derivative of b times a, and then we have just a single term, so minus the derivative of x is just 1, derivative of c is 0, and we have 1 over x times x, which is 1, minus 1 is 0, so we get ln x. So this is a correct antiderivative. You could factor an x out of this and call it x times ln x minus 1 as the antiderivative of ln x. Okay, now let's go on. Let's do another one. What would happen if we had to do the antiderivative of from 0 to pi over 2 had a definite integral of something like t sine of t dt? Well, we've done something like that already, but I'll do it again here. I'll make my table. I'm doing it blue here. I'm going to let u be the t, so du will be dt, and v will be sine t dt. So its antiderivative is negative cosine t. So, filling out here, we got t times uv is negative t cosine t. And then we have minus the integral, the antiderivative of these two, which is minus cosine t dt. And so I need to evaluate this between 0 and pi. Well, this has no integral on it, so I could say evaluate that from 0 to pi over 2. And evaluate this from 0 to pi over 2. So, before I do the evaluations, let's get this antiderivative taken care of. So I'm going to write minus t cosine t. And we have a minus, which is plus, and the antiderivative of cosine is sine, so I get plus sine t. And I normally would put plus c, but since I'm doing a definite integral, I don't need to. So I got to do all of this part and this part from 0 to pi over 2. So I get negative pi over 2 cosine of pi over 2 plus sine of pi over 2. That's putting the pi over 2 in. Minus, then we put the 0 in, we get negative 0 times the cosine of 0 plus 0 plus sine of 0. Now, what's that work out to be? So cosine of pi over 2 up here is 0. So 0 times minus pi over 2 is 0. And the sine of pi over 2 is 1, so this is plus 1. And then 0 times cosine is going to be 0. And then we got minus sine of 0, which is also 0. So we get 1. Now let's check that. So we'll pull out the calculator. Definite integrals, we can have the calculator do them for us and get a decimal approximation. Hopefully it's close to the same. Go to the y equals and type in t sine t, or x sine x. Make sure my mode is in radians, and then I can graph. And let's go zoom 4 for a little bit different graph looking. And we need to graph from 0 to pi over 2. So I go second, calculate the area. I mean, not graph. We need to find the integral from 0 to pi over 2. From 0 to second, up arrow, pi divided by 2, enter. And it says the area of that is 1. So they match. Okay. One more. Maybe two more. Where's that other one I had? Okay. Yeah, we're all right. So one more. And this is the integral of e to the x sine x dx. Now, how are we going to get this one to work? Well, we'll try integration by parts. Now, on here, the t got simpler, or the x squared got simpler, and then the 2x got simpler on that one up there. But when you take the derivative of e to the x, it doesn't get simpler. If you take the derivative of sine x, you get cosine x. So things are not getting simpler. Is this one doomed to fail? So let's see. If I do u and v, so I'm going to let u be e to the x. So du would be e to the x dx. If I do that, then the sine of x dx has to be v prime. The antiderivative would be negative cosine x. So this would become uv, e to the x times negative cosine x minus the antiderivative, the integral of these two, which is e to the x cosine x, and there's a minus, and there is a dx. And so the minus cancels. So I have minus e to the x cosine x. And this, let's not write that here. Let's go over here. So I'm going to have minus e to the x cosine x. But I have to do the antiderivative of this, which is a lot like this, except for instead of sine, it's cosine. So maybe this might not work here. Let's see here. Let's try u substitution once again. Or integration by parts once again. So I'm going to do u and v, and I'm going to do the function and its derivative. And I'm going to do the same part. I'm going to put e to the x here. So the derivative be e to the x dx. And I'm going to put the rest of this, cosine of x dx, down here. So the antiderivative is sine of x. And so I get, and this is plus, so it's plus uv e to the x sine x minus the antiderivative of this way, which is e to the x sine x dx. Uh-oh. That is the same as what we started with. So if I try to do that by integration by parts, I'm going to just keep going. But since this equals all of this. It's like an equation where x equals some numbers minus x. I can add this to both sides. I can add the integral of e to the x sine x dx to this side of the equation and to this side. And I get two of these. So I get 2 integral of e to the x sine x dx equals negative e to the x cosine x plus e to the x sine x. Now, since there's 2 of these, and I only want to know what one of them is, I can divide this side by 2, and I can divide this side by 2, and I've found the antiderivative of that. Oh, except we probably should put plus c. Okay, so this would be, let's see if we can simplify this a little bit. I got a half, and then there's an e to the x in both of these. And then I would have a sine of x minus cosine x. A minus cosine x and a sine x plus c. So let's do the antiderivatives of this and see if it works. So this is a product. I'm going to call this A and this quantity B. So the derivative of this would be 1/2 e to the x times b plus, now I'm going to do the derivative of b, which is derivative of sine is cosine x, and the derivative of cosine is negative sine, so negative negatives plus sine x times a, which is 1/2 e to the x, and the derivative of c is gone. So what do we have here? 1/2 e to the x times sine x plus 1/2 e to the x sine x. So that's a half of e to the x sine x and another half. That makes a whole e to the x sine x. So that's what I want. So hopefully the rest of this cancels. Well, we have 1/2 e to the x times the negative cosine x and 1/2 e to the x times the positive cosine x. So those are going to cancel, and I'll have that. So it works. Now, I'm going to do this problem again. What if I had chosen to do these the opposite direction? So, if I do this again and say, okay, f and f prime, and I chose u to be not the e to the x, but the sine of x, and put e to the x dx down here, then when I take the derivative of that, that's cosine x, and the antiderivative of this is e to the x. This would become u times v, e to the x sine x, minus the antiderivative of these, which would be e to the x cosine x. Oh, I forgot the dx. dx. And now I've got this. So we'll need to do integration by parts again. So I'm going to again put the trig function as the u. So cosine x and e to the x dx. This integrates to e to the x. This becomes negative sine x dx. And we get e to the x sine x minus uv cosine x times e to the x minus integral, the antiderivative of negative sine x e to the x dx. So I have e to the x sine x minus e to the x cosine x. Minus a minus is plus, but then this minus makes it minus the antiderivative of e to the x sine x dx, which is the negative of what we started with. So if I add it to both sides, I'm going to get the same result as I have right here. This divided by 2, because I'm going to add it over to here, have 2 of them, divide by 2, and I'm going to get the same answer. So it didn't matter which way I put the u and the v on this, if I kept going the same way. Now what I should do is one more attempt at this. What if I did the integral of e to the x sine x dx and did f and f prime u v? If I put, let's say I put the sign in here and took the derivative, it'd be cosine x dx, and put e to the x dx here. Antiderivative would be e to the x, and this would become uv sine of x times e to the x minus the antiderivative of e to the x cosine x dx. We've done that. Now, here's what some students sometimes do, and notice what will happen if we do this. They said, well, this didn't get me anywhere, so why don't I do it the other way? And they say, well, let's put the e to the x here and the cosine of x dx there on this piece. So the derivative here is e to the x dx. The antiderivative here is the sine of x, and this becomes sine of x e to the x minus uv e to the x sine x minus the antiderivative of e to the x sine x dx. And what happens here is we have e to the x sine x minus e to the x sine x. They cancel. And we got minus a minus, which is plus, and the integral of e to the x sine x dx. And we're right back to where we started. So doing it with the trig here and the e there, and then doing it backwards, the opposite way on the second time, doesn't get us anywhere. We just end up undoing what we did the first time. And that would happen even if you started with e to the x and sine x here, and then switched them and did sine x, the cosine and e to the x here. So you don't want to. You want to keep trying it the same direction. Okay. All right.